Question 20. Show that 1 over x minus 1 minus 1 over x plus 2 equals 2 over x squared minus 1. This is just a matter of algebra, colleagues. Okay, should I call a grade 12 to solve it for us? Should I call my grade 12 cousin to come and solve this for us? Mr. Vincent? Should I bring my grade 12 cousin to solve this for us? Okay, colleagues, yeah, you just show it's just like basically we solve this. Okay, remember fractions when you multiply the denominators. Colleagues, when you multiply the denominators, what do we get? Let us solve. What is in our denominator? Are we getting this? Then 1 positive 1x minus 1x 0. Are we all getting this, colleagues? In our denominator, please don't be quiet because I'll feel scared now that this grade 12 work. Yes, colleagues, are we all getting x squared minus 1? Or we're still calculating? Okay, wonderful, wonderful. Then remember, x plus 1 times 1 minus x minus 1 times 1. Okay. Now, whenever there's a negative sign before a bracket like this, distribute the negative. Negative 1 times x, negative x. Negative 1 times negative 1, that's positive 1. Grouping like terms together. So x minus x, 0. 1 plus 1, 2. So I get 2x squared minus 1. Are we okay with this, colleagues? Hmm. Yes. Wait, just hold on. You're saying when we do what? Huh? The cross multiplication has happened already. Okay. Or if you want, we can put it like this here. Okay, this 1 times x plus 1, then this negative 1 times x minus 1. Then you expand. Yes, yes. Okay. Can anybody answer that? X to the power 2 minus 1. Can you see on top? Oh, Madam Sylvia. Yes, before I. Yes. There's a, are you able to handle that query or should I handle it? Hmm. Hello. What's up? I'm still. So can I go and try first? Okay. We can move on. Now they want us to integrate this. Okay, they want us to integrate 2 over x squared minus 1. Okay. So here the u substitution cannot work. Okay. Because of this x squared here. So what you're supposed to do is this same fraction, bring it back to its original components. 1 over x minus 1 minus 1 over x plus 1. Okay, you bring it back to its original components. Then now you can integrate. Do we remember how to integrate this? From question 11, partial fractions, the second part. Do you remember this formula? No, sir. Question 11 was 2 months ago. We've forgotten it. Okay, colleagues. Whenever you have a fraction, okay, especially for a linear factor, in these ones where the x is to the power 1, okay, you can apply this rule for integration. Okay, you cannot use substitution. Okay, but if these at the bottom, if they had powers, for example, it was like to the power 2, and this one maybe to the power 3, then you can use substitution. So here, since use substitution cannot be used, you apply this law. So 1 over x minus 1, you just say natural log of x minus 1. Then we derive x minus 1. Colleagues, if we derive x minus 1, what do we get? This is what this dy dx at the bottom is saying here. Okay, you derive this, which is in these brackets here, you derive it down here. So here we're deriving this x minus 1. So what's the derivative of x minus 1? Is this where the Greek has begun? Are we now listening to Greek? Yes, 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 yes. It's now become Greek. Huh? At first, there it was all English, but now here, moment I put this, it's like my language changed. Like I was speaking Greek now. Yeah, so it's like it's like you're doing integration and differentiation, basic. But just remember, colleagues, okay? If you have a linear factor here, x to the power 1 at the bottom, okay, just get the natural log and you derive. Okay. So what's the derivative of x minus 1? Have we forgotten how to differentiate? It's 1, yes. Colleagues, do we know, are we all comfortable with how this one came about? Are we all comfortable with how that one came? Hmm. Madam, let's start with the roll call first. Yes, Madam Yvonne, are you okay with how that one came about? Madam Florence, are we okay with how that one came about? Madam Betha? Okay. Remember, when you are deriving, so this is like x to the power 1. When you're deriving, you multiply exponent times coefficient. So this x, the coefficient is 1. So 1 times 1, that is 1. Then you will always subtract a 1 from the exponent. Okay? 1 minus 1, that is 0. Okay? So our answer is 1. Okay? Then, as I said, integration and differentiation are related because if we integrate 1, okay, we integrate 1 becomes like this. Remember, with integration, the exponent, you add a 1 to it. What you do with the exponent, you do in the denominator. Now, x to the power 1 over 1, which takes us back to this here, this x to the power 1. So when we derive, yes. So when we derive x to the power 1, we get 1. When we integrate 1, we get x to the power 1. So that's how these two things are related. Then this here, have you seen this one here? Numbers by themselves, they disappear when deriving, okay? You don't need to show how it disappears. So that's how this one came here, madam. So what about for the second one? Where x to the power 2, where are we? Oh, you're asking about this. Well, we're on, we're on this part here. Yes, we've shown that this equals this. That it ended where? It ended once. Yes, it ended here. Then now we've gone to the second part. So I say that the way this fraction is, you can't integrate it as it is because if you try your substitution, it will fail. So this fraction, you break it down back to its simple components, and then you integrate. Okay. I can imagine the confusion you are in, like, now ways. What's happening? Okay, no, at least we are back on track. So this 1 over x plus 1, when you integrate natural log x plus 1, when you derive this one below here, x plus 1, what's what do we get? 1. Hey, no one said it. I was even scared now, like, Okay. So I believe most people are wondering, these 3 and 2, what is their purpose? This is where they come in and now. Here we're integrating with limits. Okay. So here that's why there's no plus C. Notice I haven't put any plus C around here. Okay. So what's going to happen is these 3, we're going to substitute it here and here. Then we subtract it from when we substitute these 2 in here and here. Okay. The 3 is the upper limit, the 2 is the lower limit. Okay. Upper limit minus lower limit. So first we substitute 3. So natural log, so where there's x, we substitute it with 3. Natural log of 3 minus 1 minus natural log 3 plus 1 minus. Then next we substitute the 2, which is the lower limit. It says natural log. So where there's x, we substitute it with 2. So 2 minus 1 minus natural log of 2 plus 1. So in your calculators, okay, in case you get a negative value for any of these, since there are these 2 lines here, it means absolute value, meaning you ignore that negative sign. Okay, colleagues? That's what these 2 lines mean here. Okay. So here we start with the natural log of 2. 3 minus 1 is 2 minus natural log 4. Okay, 3 plus 1 is 4 there. So let's do it. Natural log of 2 minus natural log of 4. If you, if you get a negative value, you ignore the sign, okay? So you want to represent it as negative because of those 2 lines. So what is natural log of 2? Mm-hmm. Colleagues, we're not seeing natural log on our calculators. Or is it giving you parallel answers? And the answers are so parallel that you just don't even to mention them. Yes, what are we getting as natural log of 2? Don't go and press log 2, no. When there's ln on your calculator, just put ln 2. Don't look for these. Maybe are you looking for these symbols, these lines here? Just put in natural log of 2. If you get a negative value, then that's how you know that, okay, you ignore it because of the absolute value lines. Okay, natural log of 4 1 point. Okay, close brackets here. Natural log of 1 minus natural log of 3. Okay, 0.69 minus 1.3. Sir, you are misleading us. You're misleading now. No, it's okay, sir. 0.69 minus 1.38. This one will be negative 1.09. Hmm? This one negative 0.69 also. Oh, 18. Oh, okay, yeah, yeah. Negative 0.69 minus negative 1.09. Mhm. It is. Mhm. Negative 0.69 plus 1.09. 0.4. Okay.